Okay. All right. So here we go. Sorry about that. So when it comes to tessellations, I don't know if you remember that, maybe in grade 9, but I really think of them as tiling questions. And so sometimes you'll be asked to figure out whether or not you can use certain shapes to tile a floor. Okay. So that's where this comes in. So let me just get this on page 49. Okay. So sometimes you'll be asked to whether or not a shape or a series of shapes will tessellate. Okay. Can be used for tiling. And you need to basically figure out, find out if the interior angles have a sum of 360 degrees. Okay. That is basically, I'm going to use a different color for that. That's really where it all hinges. Find out if the interior angles have a sum of exactly 360 degrees. So I give you some visuals here so you can tell right away whether or not they can be used to tessellate. So if I asked you irregular triangles, if they can be used, you can tell you got to focus on one corner, and what you want the 360 degree around this point right here, right? So that's the idea. If it's a regular triangle, what are the interior angles of a regular triangle? N is equal to 3, correct? So we go 3 minus 2 times 180 divided by 3. Some of you need to make sure you have this formula right. And a regular triangle is really an equilateral triangle, correct? Would you agree with me on that? This gives you 180 divided by 3, so it's 60 degrees. Every single interior angle here is 60. So in this case, we focus in on these interior angles here where they meet, even though every single interior angle of every single triangle is 60. I just focus in on this point right here. Okay, so this is how you would show it in this particular case. You would go 360 degrees divided by 60. Okay, so this angle right here, we use that. We want to find out how many times does the 60 fit into 360, and we know, right, that 6 triangles is the answer. Okay, an exact number. Therefore, will tessellate. Can be used to tile the floor. If you divide and you get anything with a decimal, you cannot use that to tile the floor. Okay. Another more tedious, another method would have been, we take 360 and we start subtracting that interior angle of 60s. And in this case, we would have to do it how many times? 6 times. And then you end up with 0 degrees. Okay? This is another method. Sometimes we will actually use this. Okay? So I'll just say right here, another method to show if tessellation happens, right? Very messy. All over. What about regular pentagons? You can tell it's not going to work, right? Like you've got 1, 2, 3, and then there's a little bit left over. But this is because if you don't have an image, you need to actually show it here. So you find the interior angle of a pentagon. We're talking 5-sided. So we go 5 minus 2 times 180. Anybody remember what that is? The interior angle of a pentagon? 108, right? but maybe don't rush, right? If, 108 degrees. So check. We go 360 degrees divided by 108. If you do that, you get 3.3 repeated. Okay, so it's not going to work. Okay, that's what you get. Doesn't work. Can tessellate. Okay, you cannot tile a floor using pentagons. Can use regular triangles. Okay, we're doing triangles, squares, and hexagons, right? To tile a floor, right? Will this tessellate? And so again, when the question asks this, if you can use these, you must use one of each minimum, right? You can't say, oh, I'm just going to use triangles, that's going to work. You have to use one of each, but you can use more afterwards, okay? You have to use one of each for sure, and then you may use whatever else you need to complete that. So obviously at this point here, we would focus here, and we would check this angle, the triangle, the square, and another square, right? You can tell that you have a 360 here. And it's going to work, but here's how I'm going to show it. I'll find the interior angle of a triangle. I give you full permission to just say it's going to be 60. It's an equilateral triangle. The interior angle of a square, what is that going to be? It's going to be 90. You can use the formula. It's nothing against the formula, but I think in this case, it's too much work. And interior angle of a hexagon, if you don't remember, it's this, right? So that would be 4 times 180 divided by 6. That ends up being 120 degrees. So I would always start with, let's figure out the interior angles here. Can you do the division part here in this case? You know how I checked earlier? We were only dealing with one shape. You go ahead and do that. In this case, you have various angles, so I will go like this. I start with 360, and I start subtracting one of each. So you've got a triangle, a square, and a hex. Okay, you've used one of each for sure. Okay, and then you end up with 90. You end up with 90 degrees left over. Do you have a shape that's going to take care of that? You have that 90 here, right? So we subtract one more 90, one more square, and then the goal is to end up with nothing, like no degrees left over. The entire 360 degree space has been filled up. Okay, so now you will say yes, they will tessellate using, now you need to answer, right? One triangle, two squares, and a hexagon. So if you keep this pattern, I will see if it opens later on. I have the software I use to make this. We can clone this piece, keep cloning it, and I can show you, you could keep tiling indefinitely. It would always work. You just need to check one intersection. If you can fill this up, you will be able to fill the whole floor up, no problem. Okay. So don't think it always works, and also don't think it, right? it doesn't work all the time, so you have to check for sure. So what about using a triangle, a square, and octagons? I'm not going to attempt to sketch that one, but these three shapes, again, triangle is 60, square is 90, so I give you permission to do that if you have most of them there. An octagon would be 8 minus 2 times 180 divided by 8. That is 6 times 180 divided by 8. It's 135. degrees, you got it all. Now we're going to go, we start with 360, take away one of each. So you end up with 75 degrees. Okay, so there's a triangle, a square, and an octagon. You took one away of each. Is there a shape that can chip off a bit more? You could probably take off another triangle, but there's nothing that will take care of the 15 degrees. There's no shape within the options we have here. There's no shape that will do it, right? Left, over, okay? Can't tessellate using these shapes. I want you to go to, I want you to also understand, okay? Just look up here. I'm just going to grab this middle example again. Sometimes you may be encountering a scenario where I give you two shapes, and I may ask you, what's the third shape that can be used to tessellate? What's the third shape? Okay. So you'll subtract, and then you'll be left over with something, right? A certain degree amount. Remember backwards how to find the number of sides? Does that ring a bell? Right? That's what you're going to have to do to figure it out. And this was fairly easy to know that it is a square, but if it's anything else, you might have to do a little bit of work to get that before you answer. Okay. So I'm going to ask you to try page 50 here, real quick. Answer both of those questions. You can ask me, you can ask your neighbor, just as long as you're quiet, right? So try page 50. You're applying the knowledge to things you just learned. It's not a whole lot of work necessarily, but you need to know how to do it, right? So page 50, let's take a few minutes and then I'll do the next part. Okay. At least have it, and then we'll do the next part. Maybe I'll just show you the key. It's a little messy, but you can make it work. So yeah, if you're using regular octagons, you find the interior angle of an octagon, it's 135. You may use this fact to quickly realize that you can't use octagons, right? You can't use octagons because there's no combination that adds up to 360, right? Or you don't have a whole number of tiles that will make that work. It says what other shape can be introduced to tile the floor. Start with 360, subtract. In this case, I subtracted 2 octagons. I'm left with 90. You know what? If it's just 90, you go ahead and just say a square can be introduced. But what this is saying is that you need an interior angle of 90 degrees, which means that the exterior angle is 90 as well, right? If your interior is 90, your exterior is 90 as well. And then I use the exterior angle formula to figure out that you need a 4-sided shape. I know this is overkill. You didn't have to do this. So a regular quadrilateral, Therefore, a square may be used, may be introduced to make this happen, right? So you kind of solve the problem in order to tile this floor. You just need to get squares and octagons to make this work. In particular, 2 octagons and a square at every intersection, okay? That's how this is going to work for you. The next one here, it's very sluggish, my computer. I don't know. They redid it, something on Friday. In this case, a floor designer, right, wants to use regular polygons. That tells us that we can use the interior angle formula, right? The Tyler uses 3 different shapes, all with the same side length, right? At each corner there's 1 square, 1 hexagon. What's the third shape? Okay, so square, hexagon. You start with 360, take away the square, take away the hexagon, you're left with 150. Watch what I do there, okay? So basically, when you get to 150, you need a shape with basically angle I being 150. That's what that is saying, okay? So I use that. Some of you stick with the longer method of finding the number of sides. You go for it. There's no problem with that. But I immediately find the exterior angle, which is 30 of the shape we're wanting, right? So then 30 is equal to 360 over n. This is the formula for the exterior angle. You cross multiply and divide to get 12 sides, okay? So the third shape needs to be a 12-sided polygon. In other words, a dodecagon if you have the name for it. And that's how you do tiling questions. So it's either does it work, or sometimes does it work? If not, what should be introduced to make it work? Okay, so that's kind of the only thing that you have to watch out for. So when I give you the quiz back, the one question that I told you to skip, you can try it as practice, right? To make sure you know how to do it. All right. I'm going to stop this video here and start a new one. We're going to go back in time, 47.